Basically, our sensor works like this. There is an infrared LED that sends a light in front of the sensor. If there isn't an object, nothing will bounce back in the phototransistor. If there is an object, the light will bounce back and the phototransistor will have a current that can be amplified and used for determining that the object is present in a desired range.
For the implementation of the circuit, we used very simple components: an infrared LED, a photoresistor, an integrated circuit LM358, which is an operational amplifier, a couple of resistors, a potentiometer, and a green LED to represent the output signal. As we're using the LM358 as a comparator, the voltage of reference will be that of the potentiometer. The input voltage will be that of the resistor that comes after the phototransistor. The infrared LED will be connected to VCC, then to a resistor, then to ground. The output signal of the comparator will be connected to the green LED, then to the resistor, and then to ground. The positive feed-in terminal of the comparator will be connected to 9 volts and the negative to 0 volts, so as to create a logic level high and logic level low. The first characteristic that we decided to test and measure was range. First, we calibrated the sensor to its maximum potentiometer value. Then we placed a ruler to one side of it and an object far away of the sensor. We slowly closed the distance between the sensor and the object, and when the first detection arose, we took that value as the maximum range. As you can see, you can calibrate the potentiometer as to have less and less range. For hysteresis, we did two simple tests. We took the object and placed it at 23 centimeters. Then we slowly started approaching it to the sensor. Second, we did the same but backwards. We took an object and placed it at 19 centimeters and slowly moved it away from the sensor. Now, the first value was 21.1 centimeters and the second one was 20.9 centimeters. Doing the math gives us a hysteresis of 0.943%.
Selectivity was tested by applying some heat to the sensor with a hair dryer. It did not affect its functionality. In conclusion, I realized that a physical sensor can be built almost from scratch, and that I can adapt it to my specific necessities, since I am designing it. I also realized that it's very important to know the physical characteristics of the components I will be using and how they interact with each other. Another opportunity would be the calibration of the sensor, since it's a small area and it was difficult to find. So what I would do is to have a greater space, and I will make that by having a potentiometer which makes smaller changes in its resistance.
I think I really enjoyed the project because analyzing the data that resulted from the endeavor really made me understand more deeply, all the concepts that we were taught in class. I think the most difficult part of the project was the recollection of useful and worthy information to comprise such a project and to make every player fall into place. And I think our sensor has a few disadvantages, in the precision category. which I think it has to do more with the inexpensiveness of the project rather than a miscalculation in our part.